Howdy there, geology scholars. This is Tom Johannesmeyer. In this video, I want to explain about the sidebar features of Google Earth. The sidebar is essentially this whole left-hand column of Google Earth, and it has three parts. There's the search sidebar, the places sidebar, and the layers sidebar. Search sidebar is fairly simple. There's a fly-to function where you can enter in zip codes as well as city names, mountain range names, and so forth. Hit enter, and you can fly directly there. You can also find businesses and directions. In this first lab, you're not going to need this search feature unless you don't know where Port-au-Prince, Haiti is located. So for right now then, I'm going to go ahead and assume we don't need that, and I'm going to minimize it. The places sidebar will be covered in another video, and now I'd like to just focus your attention on the layers sidebar here. This is where the heart of Google Earth is located, in my opinion. You basically have things like roads, borders, and labels, as well as terrain, which is actually selected. Now this terrain layer right here is actually a three-dimensional model of the entire surface of the Earth. So you could zoom into any mountain range and fly around the canyons and across the peaks and so forth. It really makes Google Earth a lot of fun, as well as an excellent tool for teaching geology, because I can take you on field trips, essentially, to places all over the world. Well, lots of other content here that you're just going to have to play with on your own time. It's a lot of fun and very educational. But what we need to know is we need to load up a earthquakes layer. And that's found under this gallery option. So I'm going to click on that plus sign there and expand that gallery option. And you can see there's an earthquakes feature there. And I can check that box there to load that up. Now this is an earthquake layer. It's earthquake data from the United States Geological Survey. It's generally earthquakes in the last 90 days, but if a large earthquake occurred in the past, it's still shown as well. Unfortunately, when you look in the global view here, those earthquakes don't appear at all. You have to zoom in. So we're going to zoom in here then on Wyoming, and you can see now earthquake icons are starting to appear. Zoom in a little bit more. And to get the information from the earthquake, all I simply have to do is simply click on the icon. Click on that, another box opens, and it gives the Richter magnitude of the earthquake, where the earthquake was, the date and time of the earthquake, as well as the depth. 4.35 miles in this case was the depth of the initial rupture that generated this earthquake. So that data is found right there. You can see that that's really recent. This occurred actually Wednesday, January 13th. And you can click around here and see all these other earthquakes also. I won't click on every single one, but they all occurred in 2010 within the last couple of weeks or so. Now, one thing you do notice, and I'm going to zoom in on this area a little more, is as I zoom in, you notice that other earthquake icons pop up also, and they're actually larger, which indicates that they're larger magnitude earthquakes. This one here, I'll click on that one. This is one of the largest earthquakes ever to hit Yellowstone, a magnitude 6.1 on the Richter scale. That would have definitely been felt. That occurred in June of 1975. So the reason why that icon wasn't visible in the more zoomed out view is because that earthquake occurred a really long time ago. Okay, so as we zoom out like this and look at those views at this scale here, we generally just see earthquakes that have occurred fairly recently. Okay, so how do I find the actual location of the earthquake? Well, that's really simple. You notice on the very, very bottom of the screen right here, I have a latitude, a longitude, and an elevation. And that continually changes as I move my indicator hand around the screen. So basically, wherever that indicator hand is located, the latitude, longitude, and elevation is given then on the bottom. So all I have to do then is simply hold my mouse over that earthquake location, and then the latitude given below and the longitude given below and the elevation correspond to that location. So in this case here, that earthquake there that occurred more or less east-southeast of Jackson occurred at 43 degrees, 28 minutes, and 28.74 seconds north latitude, and 110 degrees, 22 minutes, 10.88 seconds of west longitude. Now, for our instances, for our case here, just round that to the nearest degree. You can see the elevations given also. Now, another thing we also need to do in this first lab is make some very simple measurements of distances. So how you do that is using the ruler tool here. So I'm going to go ahead and click on that, and then another window will open. You can see that I can actually measure the length of a line or a path. Now, line, of course, is just simply 2 points. A path is a series of line segments. So when I measure a line, I can also specify what units I measure it in. You can See, we'll stick with miles, but you can use all sorts of other ways of measuring distance, even the smoot. You can look that one up. So once I've selected that window's open, then you can see in the actual view screen, I can now have a crosshair. So I can simply click the first point at the beginning, and then the second one. Let's come over here and measure the distance from that earthquake to Sheridan, for example. And then click to the end point. And you can see that the length is then given right here. And then the heading of the line is also given. The heading is basically the compass direction from beginning to end. In this case, it's nearly east. East is 90 degrees, and we're a little bit shy of 90 degrees, so it's slightly to the north of east is the direction that line heads. So that's how you measure distances in Google.